Hi, welcome to CC 373, Section 4. This is a micro teach on hashing. So first, we're going to discuss what hash table is. So essentially, this is a one way to implement the dictionary ADT. So we have some dictionary ADT such as tree map and hash map in back in season 143. You can see that what this hash table essentially does is it stores item with key X in array index. It can be or bucket in h of X. The choice of h of X is important for many reasons, and we are going to explore why it matters throughout different problems. So you can see that this put 0 fo was so at index 0, so 0 mod 10 by the length of the array, then so it was placed at 0. So remember that the array index are from 0, and then actually the length of it is due to 0 indexing, it'll be like 9 plus 1, which would be 10 in this case. And then we know that 5 mod 10 is equal to 5, so the bar is here. And also remember that modulo is something like a remainder, right? So when you divide something that's like less than yourself, then you'll just get the number itself. And if you can kind of think about why this modulo is useful, because if you were passed by a value like a 12, then 12 mod 10 is equal to 2. So then it'll go to index 2. So we can always like wrap around. So that's why modulo it's always so often used with array or some kind of data structure that require indexing. But here we encounter some problem called collision, right? So basically, collision is your data can be stored in one index. So for instance, we could have 100 items or maybe 1 even billion items that can just store in index 0. Then they will create more like a linked list like array. So the whole point of dictionary was essentially for fast accessing of the data, right? But in this example, we just need to traverse the data as a linked list essentially. So there will be just worst case, we might just need to iterate through the whole an item that's stored in one index, and that's not what we want. So we use something called separate chaining that uses linked lists to handle collisions, right? But like I just said, that has this potential problem. So the question is, okay, so what do we do to get those, to implement this, right? So going back to this modulo, so we use modulo of the hash code when it exceeds the number of buckets. So basically, it's the same idea we talked about the array. So when we previously talked about deck, then we will need to wrap around the different index if we go out of the bound. So for instance, you have this total array of size of the length of 10. But then let's say you're given index 12 and maybe happy, but then we don't have index 12. So imagine if you don't use modulo, you have so many if statements for, I don't know, like a lot of numbers, like, I don't know, possibly like 100 lines of code capturing that. But we don't really need to do that because modulo will capture that. So 12 mod 10 will be 2. So we'll insert the value at the 2. So there's this question here. So if we use, oops, oh, where did it go? Okay, there we go. If we use the 10 bucket below, where should our 6 items go, right? So in this case, we can do h of x mod 10. So basically just h of x is our hash function. So remember that we're going to pass in our input to some kind of secret box that's like our hash function, and hash function is really important too. And then we're going to modulo that by the length of the array. This you can think about this this outer container of this many buckets essentially. Okay. And now we have to talk about hash function quality, right? I mean, because it's some kind of magical box and that we are going to pass input in. But the key important aspect of this hash function is that the more h of x evenly distribute the key, the faster get is, right? So we need to think about why that is the case. So in this specific example, we can see that at index 1, we have 3 values, right? Potato, rotato, totato. Let's say like, I don't know, like put embedded like a tato or something, and we have so many like letters that ends and then it that essentially be located at index one. Um, or let's say the hash function can always set index to like one, right? Then no matter what's passed in, the index is always fixed of one, and when we modify the same length, then it will be just always be at the place of one, right? Imagine how tedious it will be to get your value just iterating through, like just then there's no point of having separate training, right? Then it would be just like a linked list. So in order to prevent that problem, this h of x, which is hash function, is really critical to improve our get runtime.